Welcome back. Section 2.3, the multiplication property. So we're continuing to look here at solving what are called linear equations, equations that just have an x. I mean, it can be whatever letter you want, but there's really nothing weird. And if you don't know what the weird stuff is, don't worry. We're not really doing it much in this course, so you're pretty safe. All right. So again, I have my steps up here on the board that we looked at back in section 2.2. Get rid of parentheses, clear fractions, add and subtract, and divide. Okay, so that's kind of the basics. Last time we were here, we looked at adding and subtracting to solve. Here we're going to really work on this last step, but this is a little bit simplistic. You'll see, we can also use multiplication. So we're really looking at using multiplication and division here to solve, and we'll come back to those steps later. So my first example here, ignore the 3 underneath, we have 3x is equal to 12. So in this case, we have 3 times the variable, and we really want to get rid of the 3. So this is a case where we're going to need to divide both sides by 3. That's still perfectly legal. We're doing the same thing to both sides, and so it's going to work. We divide, 12 divided by 3 gives us 4, and yeah, that works because look, if you go back, 3 times 4 is 12. Again, you can probably stare at that problem and figure out that it's 4. But keep in mind, we have nastier stuff coming, and we need these tools in our toolbox to make sure that when we get to the harder stuff, we can make this work. All right, so my other example here is this one. So 1/4 y is equal to -5. Ignore that times 4 for just a second. 1/4 y is equal to -5. So here I have a 1/4 that I want to get rid of. So this is a little bit different, and we'll talk more about fractions here in a minute when we get something a little bit nastier. But one thing we can do is we can just multiply by the reciprocal, because what happens if you multiply by 4/1? Well, if you multiply by 4/1, the 4's cancel, and you just get y, right? You get 1y, but that's the same thing. So if I multiply by 4/1, it goes away. Well, another name for 4/1 is just 4. So on this other side, since I don't have a fraction, I'm just going to multiply by 4, and that gives me the -20. So there you go. That's the real basic stuff here. Now we're going to move in and do some little bit harder examples, and then that'll be it. Thanks. So let's keep going. Okay, we're back. I have 2 more examples on the board, and then I have a really fun one for us to look at on the next board. I know I'm weird. I get it. But I'm excited for that last example. Anyway, we'll get to it. All right, so here's what we have. 4 plus 8 is equal to -2x plus 5x. So the first thing that I notice on this one is that I have more of a mess than I need to have. I can do 4 plus 8 and get 12. I can do -2x and 5x and get -3x. I can do that because they're like terms, right? These are just like terms. I can put them together. The -2x and 5x are like terms. I can just put them together. So when I combine my like terms, I get 12 is equal to -3x, and so then I just have to divide both sides by -3 to get -4. Now, one thing that I have noticed in my years of teaching, and that's worth watching out for, people sometimes, when you have this negative here that you're dividing by, they bring it over, they write down over -3, and I think it's because it's a negative sign, and a negative sign looks an awful lot like a subtraction sign. I get a lot of like 12 minus 3 instead of 12 divided by -3. So be careful. Please pay attention to what it is that you're actually trying to do. In this case, we're dividing. We're not subtracting. We're dividing by a negative. And that's different. And so we know that that's what we're doing because this was multiplication. So just be careful. I don't actually think anybody that does it really thinks they need to subtract. I think if, in my experience when I'm like, that was division, they're like, oh, yeah, that was division. So just be careful. Watch out for it, but it does happen. All right, second example. 4x plus 3 is equal to 2x minus 7. So again, I have 4 pieces here. I have x's on both sides. I have numbers on both sides. Something has to go away. You could literally pick any of those 4 pieces to go away first, and it would work. I like to get rid of the x's first. That's me. I like to do that first. It's always where I start these problems. So I chose to get rid of the smaller one, just quite simply because I want to do 4 minus 2 and get a positive 2. If I did it the other way around, I could do 2 and then subtract the 4. 2 minus 4 would give me a negative 2x. It doesn't make any difference. You will get the same answer. I just prefer to work with positive numbers. I think they're better. So once I do that, I get 2x plus 3 is equal to -7. Now the 3 has to go away because, again, I'm trying to isolate the x all by itself. So I subtract 3, and then I'm left with division for my last step. And if you remember back to that list of steps that I had, division to get rid of the number attached to the x, that is always the very last thing that you do. Okay, don't try and divide way back up here where you have lots of other stuff going on. It should always be when you get down to a number times x, and that's it. Okay, then you do your division. All right, well, anyway, we've got one more example. Let's go ahead and get it on the board. All right, last example. This one's fun. I think so. I know, I'm weird. I get it. So, really sorry about that. Especially if you're in one of my classes and you're actually stuck listening to me. I'm really sorry that I'm so weird. Anyway, I'm babbling. Let's do the problem. Here it is. 1/2 x minus 3/4 is equal to 2/3. Uh-oh, that's not fun. That's a bunch of fractions. Okay, so while I know that it's fun for me because I'm kind of weird, for a lot of you, that is definitely not going to be the case. You're going to look at that and go, oh my gosh, why did he give me all those fractions? So let's see if we can do something about that. If you remember the list of steps that I gave you, step 2 was to clear any fractions that you might have. The way we're going to do that is we're going to find a common denominator, and we're going to multiply everything in the problem by that common denominator. Okay, so for this problem, we have denominators of 2, 4, and 3, and we're going to find a common denominator. It happens to be the best one here is 12. Are there other ones you could use? Sure. 24 would work, 36, lots of things. But 12 is probably the best one because it's smallest. So all I'm going to do is I'm going to take each piece of my problem and I'm going to multiply them all by 12. So you'll notice I brought over here on the side, I have all the different parts of my equation, and they are all being multiplied by 12 over 1. I use 12 over 1 because I've got fractions, and it's just easier if I have it over 1 so I can see the fraction. So anyway, what happens? Well, the reason this is great is because since we're using a common denominator, that means 12 is divisible by all of the denominators that we already have. So 12 is divisible by 2. I can reduce that. I get a 1 there and a 6 here. 1 times 6 gives me 6x. Same thing here. It's divisible by 4. I get a 3. 3 times 3 is 9. Same thing here. 12 is divisible by 3. I get a 4 this time. 2 times 4 is 8. And guess what? Now we just take those 3 pieces that we just got and we use them as replacements for the nastiness in the problem. So there's my 6x. Notice I brought down the minus sign. Please don't change it to addition. That'd be bad. But we have minus 9 and it equals 8. And man, that looks way better. I am guessing, you know, if I give you this, you'd be like, okay, not too bad. And if I give you that, you're like, yeah, I get it. That's how it works. But this is a way you can get around it. Now, you're still dealing with the fractions. I understand. So that means it's maybe not going to be your favorite thing in the world. But it is a trick that we have. It works really well. Do a lot of practice on this, and you'll get good at it. So let's finish it up. I have a minus 9, so I add 9 to both sides. That gets me 17 on the right. I have to divide both sides by 6, and this might be something else you don't like. 17 divided by 6 is just not very nice. It's a nasty-looking decimal. Well, personally, for me, I like fractions. I would much rather have an answer of 17 over 6 than whatever that decimal is. I'd have to pull my calculator out, but so I'm just going to leave it as 17 over 6 instead of getting nasty decimal. So if you're one of my students, if you get an answer where you have this division and it turns out to be a nasty decimal, just leave it as a fraction. It's really better. All right, so there we go. We have one more section left for covering solving equations, but the nice thing is it really just kind of ties everything that we've done together. And so you'll see that when we get to the next section. Bye. Have a good day.